This is for SDA 2023, Summer 2012, Term D. Question was asked, among 45 to 50-year-olds, 29% say that they have called a talk show while under the influence of sugar. Suppose that 7 45 to 50-year-olds are selected at random. What is the probability that at least one has not called the show while under the influence of sugar? And so that's part A. Few things you should note. First off, 29% say they have called a talk show while under the influence of sugar. And in part A, you want to know the probability at least one calls while not under the influence. At least one. Remember, for the probability of at least one, it's kind of like the complement probability. Probability of E raised to C is equal to 1 minus the probability of E. And remember, this was for the complement event. Now note, since you are selecting 7, you're going to take this probability of E, use your multiplication rule, and raise it to K, where K is the amount you select. Not this is your not thing. How many are you selecting? So in part A, and remember the last sentence of the summary of your question says, suppose 7 are selected. So 7 is your K. And when it said probability that at least one has not, that was your probability of EC is equal to 1 minus the probability of E raised to K. we found out that K was equal to 7. Now, what is the probability that they will call while under the influence? So that's where you get your 29%. Now, should I write 29 for my percentage, or should I write 0.29? Yeah, you need to have it in decimal form, so 0.29. Remember, K was 7. So this symbol P of E, all of this is replaced with 0.29. Probability, that C up there means complement, which is not. So probability that they're not under the influence is equal to 1 minus the probability that they are under the influence raised to 7, where only the probability is raised to 7. So in your calculator, you're doing 1 minus 0.29, the hat is for your raised, to 7. Press enter. It said round it to 4 decimal places. So when you look at this, it's 0.9998. Since this is a 2, you're not rounding up the 8. So 0.9998. And this was for part A. For part B, you wanted the probability that at least one called while under the influence. So there's no complement here. So you're finding the probability of E is equal to 1 minus the probability of not E. And then since you're selecting 7, taking this probability and raising it to 7, or K. For your formula, you raise it to K, and then when you plug it in, your K was 7. So remember, K was what you're selecting. And we selected 7. This is has, and this is has not. So you have probability of has is equal to 1 minus, you're going to put your probability in here, and you're going to raise it to something. We've decided K was 7 because that's how many you're selecting. Now in here you need the probability of not called while under the influence. So for this, its probability of not called is equal to 1 minus the probability of called. Inside this probability is the probability that one person has not called. So we're doing 1 minus 0.29 equals 0.71. And 0.71 is what you're putting in here. So when you do this, you're doing 1 minus 0.29, and you got the 0.71, and now you're doing 1 minus 0.71 raised to 7. So 1 minus 0.71, the hat for your raise, to 7. Press enter, and you'll get your answer. Now, how many decimal places do we want? On the computer, it says 4 decimal places, and that's how many you asked for in class. So you're doing 0.9090. Would we raise this 0 to a 1? No, because the number's a 4. Only if this was 5 and higher would you raise the 0 to a 1. Since it's not, our answer is 0.9090. So part B's answer is 0.9090, and part A's answer was 0.9998. What could they change about this problem? First off, they could have changed 29% to something else. When you see probability that at least 1, that's when you're going to take the probability of whatever they're asking for equals to 1 minus the probability of what they're not asking for, and you're taking that last percentage and raising it to how many you're selecting. So that'd be 7 in this case. So they can also change the number 7. What did 45 to 50 have to do with this entire problem? Well, it didn't have anything to do with the actual math part. That was just explaining what they were talking about. Among these particular ages, this percent say they have done this particular thing. Okay, as always, if you have any questions, send me an email. If I need to make a video, will do.